Hey guys, this is just going to be a fairly short segment, I think. I want to give you an update on the project, talk about a few things, including addressing one of the comments I received, which was about how can I work down here in this mess. Yeah, it's not easy and I don't like it. I did spend a little bit of time cleaning things up a little bit, but I still got a long way to go. But the one thing I did do is I found a stand for that TV that I scrounged out of the alley. When I found it didn't have a stand, but I found an original one, a used one on eBay, and picked it up. It's pretty nifty. Kind of curves around the back and out around the front, and it's got a swivel action on it too. And the TV fits perfectly in this angled corner of the basement. And as you can see, it's working perfectly. Occasionally, one section of the backlight will get a little bit dimmer here, sometimes over there. Usually if I turn it off and back on, it's fine. So I don't think the LEDs are shot. I think LEDs pretty much either work or they don't, but maybe the drivers have an issue, or maybe it needs a recap. I'm not sure. Can't find anybody online with quite the same issue, so kind of in the dark, but generally it works perfectly, so I'm happy. Just started kind of cleaning up this area, clean up the workbench a little bit. Alright, so as far as the project goes, since I had the whole thing torn apart, I dug more into the power supply. As I talked about in the last installment, I made a mistake where I thought that this wire going from here over to the tube socket base was bad. It turns out I was misreading the wiring because it was kind of, several wires were on top of each other. It was hard to see what was going where. So I took out the offending wire, the one that I was confused about, that looked like it was really smushed under this wire and hard to see what was going where. So I took it out, lifted this wire up a bit, and installed a new wire, a black wire. Cloth covered, kind of reproduction of the old-timey wire, going from here to here. So that cleaned that up. Also, somebody had pointed out that this terminal was getting pretty close to a sheet metal screw that's coming through from the other side. So I carefully took some pliers and twisted this a little bit to get it further away. And as somebody else pointed out, if I've gone this far, why not replace the resistors, which even though they tested really good, did drift with temperature. I heated them up while measuring them and they started to drift. So I replaced them with metal oxide resistors, which are very temperature stable. So in place of the 5K, I used 5.1, which isn't exactly the same, but it's pretty close, and that's the closest standard modern value. The other was a 9K, which the closest modern value would be 9.1, but those are commonly stock, so you'd either have a 10 or an 8.2, which are getting a little bit off a 9. So I took two 18s, put them in parallel, which gives you exactly 9. In spite of these looking huge, they're really just 2-watt resistors. It's actually a 3, and these are 2 2s. And they're the same value, so the power would be distributed evenly between them. So this is actually equivalent to a 4-watt resistor. So we're fine with that respect. And I mounted the capacitors more securely. Instead of having one sticking out up here, I got it down there, kind of out of the way. And then I remounted it on this. So that is done. Ready to go. Still got some work left to do on this. I'm a little on the fence about replacing the resistors. I suppose I should, following the same thought. These are drifted off a little bit, still within tolerance, but they will drift with temperature, so I might as well replace them as well. And I should probably test that mica cap. In fact, I think I'll do that right now. Make sure it's not leaky. The other thing I was going to start working on is this, which is the attenuator. I don't want to mess with that. That is the range switch, but I do want to try to clean the contacts up a little bit. And this is a range, or output level potentiometer. And for some reason, this wire is really frayed. It looked like somebody had really gone back and forth, and it's got some metal fatigue, and some of the strands have broken loose, so it's a little tough to get at, so I think I will unmount it by taking that lug off, and also I'll try to get in there with some fader cleaner, potentiometer cleaner basically, but this looks like it's kind of sealed. I could pry up those metal tabs and take the back off to clean it, but without knowing that it's dirty, I don't know that I want to get that involved with doing surgery on it, so I think I'll just leave it be for now. And on the last installment, we talked about this guy, which got rebuilt. That's also got a mica cap, a couple of resistors on it. I guess I'll check that mica cap, replace those 2 resistors, and this assembly is just about ready to go. See that cut-off wire there? I have 1 capacitor left to replace, and I believe that's one end of it. I gotta look at my reference photos. The other cap has been replaced down in there. Now, I'm sure some of you have heard that mica caps don't go bad. Don't mess with them. Well, generally speaking, that's still true, but it's not as true as it was, say, 20, 30 years ago. As time wears on, it seems to be more and more common for mica caps to go bad, especially this domino type. It seems to vary with manufacturer, how much voltage is applied across them. This is Cornell Doublier, which is one of the better ones. Mica mold seems to be the worst. So, they're going to be pretty tricky to read these colored dots. So we got a red, looks like a red, a brown, and an orange. I'm not entirely sure what that means. So let me look on the schematic, see if we can find it. Or maybe the parts list would be easier. It's probably this guy. I'm trying to think of some combination of those colors that would give me a value that I see in the schematic. So if we read it as if orange was the first digit, and then we have multiplier. No, that doesn't quite make sense either. I guess that's supposed to be black. That's what I was thinking that it'd be. Orange, black, and red. Maybe that is black. So that'd be 3, 0, and then 2 more zeros. So 3, 0, 0, 0, 3,000 picofarads, or microfarads. And let's see, that is going to ground, and then I think on part of the switch. And that is exactly what they show that going to there. So I'm pretty sure that's what that is. Alright, so 2 things. One, let's check for leakage, and then check the value. Now, this thing runs at pretty low voltages. There's no leakage at 200 volts. It's probably plenty good, but I bet it's rated for a lot higher than that. And there's no leakage at 500 volts. So, how about the capacitance? It's kind of at the extreme of one range and at the extreme of the other range. So not so easy to read accurately. Let's see, C3 range. Yeah, it's around between 2 and 3. It's a little, try to zoom in on that. So you gotta rock the dial for maximum eye opening, which is right about there. And then on the C3 range, it's 0.0015, and the divisions are kind of funky on this. It's kind of sort of logarithmic, kind of weird when you get to the extreme ends. So if we jump to the other range, we're way over here, C2 range, it's right about there, which starts at 0.001 or 1,000 microfarads and goes to 5 over here, so that'd be 1, 2, it's like between 2.5, or between 2 and 3. This thing's not super accurate, but it's in the ballpark, and it's not leaky, so I'll call that good. So, I should maybe talk a little bit about this tester. You've seen me use this many times if you watch my older videos. This is a vintage tester. I think it's from the 40s. Probably was more like designed in the 30s, though, so it uses some pretty old school tubes. You probably never saw this before, an IV tube. It's actually a half-wave rectifier. This has been retrofitted, or maybe it was full wave, I don't quite recall, but this has been retrofitted to use a 6x5. And it's got an I-tube, and that's it as far as tubes go. Inside, it's got a bridge, a balanced bridge. There are reference capacitors. And it compares the test capacitor to the reference capacitor through this. It's been a while since I looked at this. I think we got a schematic here. The service manual, or the instruction manual. Yeah, here we go. So this would be the version I've got with the I-V tube. So I think the big variable, no, I think it's a resistor. It might be this R3 here, but I'm not entirely sure about that. But anyways, the principle is we're comparing the unknown capacitor to a known fixed capacitor, and by rotating this, it's trying to balance out the two, and when they are balanced, you can read the value off the scale. And as far as the leakage goes, it's a neon light bulb with 2 sections on it, and you can use that to, if it flashes, that means there's leakage. It's a pretty basic circuit, but it gets the job done. But as far as measuring values accurately in the picofarad range, not the most accurate thing. They certainly look cool though. Comes in a nice dovetailed wood box, and it's got the cool dial and all that, so I like to drag it out now and then and use it. But would I trust this if I wanted to know to measure a capacitor within 1%? Absolutely not. But to check for leakage, sure. Now let's take a look at that potentiometer. Loosen up the nut here. Push it through. And luckily there's enough length on these leads I can flip it around. Well, that's a little disconcerting. There's pry marks on it. Somebody's been in here and opened that up before. That could very well be why these wires are frayed. Maybe this has been taken out and manipulated a few times. Well, you know what? I am going to leave this alone until I get this working, because if it's not noisy, I don't want to pry that open again. If it is, well, let's see, what value is this? So I'm also thinking, well, maybe I could just replace it. 250 ohms. It's a fairly standard value. I think it's going to be fairly low wattage, so that shouldn't be too difficult to find a replacement for. Except the shaft. Philco used shafts that they're not half round, they're like 3/4 round, and then flatted down. Whereas modern ones, I think, are more typically, they're like 50%, they're real half moons. I've seen some people take solder and glob it on here to build it up and then file it down to make them fatter, or take a full round one and file it down until it's just enough that the knob will fit over. Or I can go through my junk box and maybe find one. Well, what the heck. just be real careful. So I'm kind of curious if it's wire wound or carbon. Might be enough. Almost. The more you do this, more metal fatigue you put on these, and you do not want to break these off. Well, worst case scenario, if you did, maybe it'd be possible to find another one and salvage the back from it, but this is kind of an unusual size. It's a little bit bigger than your typical pot. Good time for the camera battery to die. I actually considered for a moment about leaving the video off there with a cliffhanger, but no, I wouldn't do that. So that is kind of unusual. I haven't seen anything quite like that. It's like a big, old, thick slab of carbon. Usually it's just a thin deposit on an insulating base, but man, I think that's just a carbon all the way through. Wow. Well, if that is true, I'm sure it's got plenty of life left. Well, I don't know. I wonder why somebody had to open it up. So maybe the contact was worn out. Like maybe there wasn't enough pressure being put down on the carbon. Nifty. Well, let's grab an ohm meter and make sure we've got continuity. Alrighty, so here's the other two terminals. Come on. That doesn't seem right. I wonder if this little bit of coax could be shorter. Not like coax, but shielded cable. Oh, there we go. 236. Supposed to be 250. That's not bad. How about the center wiper? Grab some alligator clips and rotate it through. Alright, let's check out the action on this pot. So what's going up? Alright, let's go all the way the other way. Okay, about 0. One nice thing on these Flukes 27 is they actually have a bar graph along the bottom. Nice way to check things like this. Up, 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 up. It's a little flaky at either end, but in between seems pretty smooth. I don't think it's linear action though. See, that's about half. Well, maybe it is. It seems like at the last quarter or so of travel it doesn't change a whole lot. Like from about 200 to 250, that kind of that whole section there. But it seems to be working alright. I don't see it being erratic or jumping around or going open anywhere. So, alright. This make me wonder though, why did somebody open it up? Maybe they had to clean it, maybe they had to put more tension on that contact. I don't know. It's an interesting construction now. If any of you have seen something like this, leave a comment where it's a really, like an 1/8 of an inch thick slab of carbon, apparently. Well, that is going to be it for now. I apologize for the short video, but I wanted to get something out, and I'm not sure when I'll be able to get back to working on this. But hopefully in the next installment, I'll have this back together and we can power it up. That is all for now.